Let me give just a very
Thank
short
you.
introduction. Um, it was last September, October-ish that we signed a formal agreement with Mangosteen Singapore, which was kind of a comprehensive thing, and we chose Singapore for our own business and tax reasons. And in that, we started to describe the phases of our relationship that we were trying to accomplish. And this side of that part of our contract is actually one of the advanced phases. We were going to start with Mangosteen's type of work and selling our English program first and selling your programs as well. But as we got into the AI development in our company, which is probably a year and a half now, um, our AI has developed to a point where that has become the priority and the priority that David wanted to talk about for the future of our relationship. And so in our last meeting, he told us that you've got a database of some 8 million books that relate to your university and publishing business, and that you're already talking to a couple AI companies about what's the best use of AI for supporting teachers and students and universities at large. And so we gave David a demonstration, both David and Walter, a demonstration of the capabilities of our AI. And that sparked a new interest in us being a competitive uh, company to possibly work together in a closer association. So they asked for this meeting and to give us the sample books that Tom has forwarded to us so we could show you the process of what we do to these books and how that then lays the foundation for the various tools and functionalities for both teacher use and student use. And so I'll let Jeff take over from here and give us a demonstration.
Okay, yeah, thank you, Perry. I think first of all, a lot of the things that we're going to talk about today are proprietary, and they should be covered under our non-disclosure agreement. And we are not very sharing, actually, when it comes to our competitors, right? So we're very, very sharing with our partners, but not so much with competitors. So we would ask you please to keep this confidential. Thank you. Okay, so I think there are a number of different ways to start this conversation, and I was going to ask you. I was actually sharing my screen and maybe ask you how you might want to start this because I'm not sure the perspective from which you would best understand or want to understand. So let me share my screen and just ask you. Um, so here on this list down here, let me actually increase the size of this because it's pretty small. Oops. So can you
Have
see the,
mercy on me.
oh, I'm not sharing it. Okay, sorry. Oh, that was stop share. Was I sharing? Right. Too many computer screens. Okay, can you see the my screen right now?
Yes.
Okay, okay.
The work.
Yeah. So let me just run down these 7 items here. What I mean by fractal data is that normally when we ingest data into a vector store, and but then we want to organize that data because it comes in often pretty unstructured, you know. And uh, our initial data structuring usually we usually want to structure it in a fractal format so that we can take it very, very far with the AI. So fractal data is very powerful. Then we actually have a development environment called DataBlock where we can do highly sophisticated agentic AI development. It's just a block. I mean, you've got all these different nodes, and I want to show you that. So it's a node structure where you've got like like API, HTTP nodes, you've got database nodes, you've got GPT nodes, you've got conditional nodes, and you just stack these all together and define the parameters. And it's a multi-model, multi-prompt, multi-processing environment. It's pretty powerful. So I'll show you that. And then when we do summarization, we try to summarize into a fractal form. And so the fractal forms that a fractal format is something you design, you design, which is based on a combination of the data that you have and the purpose of the data, right? So whatever that fractal form is, kind of have to innovate that before you summarize into that form, right? So that's the summarization part. And then as far as data processing, now once you have your data sets the way you want them, what are you going to do with them? Are you going to process further assets with them? Are you going to, so this is like what we do with our lessons. We take those data sets, and from those data sets, we can auto-generate learning assets, for example, like they're derivative assets from the data sets, right? So you need those systems. And then you have interaction systems, which is, of course, querying is the obvious one, but beyond querying, right? What can you do interactively from human interaction, a user interaction beyond just a simple query? So we have a lot of examples of that. And then this is quite a important, for us, quite an important strategy. I'll show you this recursive auto refactoring. And it's a combination between, your structured relational data sets and your vectorized sets. So every relational data set, we create a vector mirror, unstructured vector mirror of that. But we always keep the original high fidelity unstructured version so that we can reference back to that. And we can do recursions across it so that it's living. Like the vector relationships are living. Anytime the data in any part of the data set changes, then it can refactor and keep high accuracy and high fidelity. Right. So I'll explain that a little bit. This is innovative from our side. It's a highly protected by us right now, actually. And then as far as creating the ontological structures, we have a foundational approach to that. Of course, this is also a vector, it's all talk about. And I guess I would just ask you guys how you would want to rearrange these numbers. Like, where do you want to start and where do you want to end?
Jeff, in a certain sense, they develop into each other, where it's really hard to separate them. They're so tangled. You may just want to start at the beginning and give us snapshots all the way through.
Yeah, Dr. Ong, Tom, would you just like me to start from number one and progress through, or do you have a preference of where to start?
Just up to you. Whenever it make the logic make sense, and then just proceed. Yeah.
Okay. Okay. Well, I think let's do data block and fractal data forms at the same time. So I have just open up a. Now we created data block as it's a evolutionary step from our original data processing or our AI IDE. And here's a automated social media campaign system that we built in like 2 days because data block is so powerful. And here's a database node where you just have to attach to your database or write your query. And this is read write, so it brings data into this development environment. It writes data back out. There's database nodes. There's HTTP nodes where you just have to define your headers and your parameters and your page source, right? And this is just the API, basically API interface. So you could have access to 20 different APIs in one of these interfaces, right? And then you just build the agentic processes to inside here. Workflow nodes are just handlers. Like from this GPT node, you're going to get the result of the workflow, which will pass it to the next workflow, which processes it again, brings it back, and passes it to the next processor, right? So workflow nodes are always on the right. There's shared workflow because this is a service which has a service parents which has child modules. So if my process here becomes too complicated and I'm all zoomed out and it's still all hairy, I might want to say, well, the data that's at this point, I want to create another module and share that data with that other module. So the complexity that you can achieve in this environment is exponentially increased by adding other modules, right? And it's incredibly powerful. We've got these really weird ones too, like here's a join node, for example. If we have a lot of data from here that we want to collect into one collection and then reprocess that, there's a join node, there's branch nodes. We've got file nodes, which is how we bring PDFs and different file assets into the system. You've got email nodes and scraper nodes. Here's the Olama parse node, which handles the parsing. Like if you bring a file in and you want to parse it, you'd have these two blocks together. This is actually these are actually two of the coolest ones. Like this conditional node here. This is like a procedural conditioning. Like I think it move this over here. So this is, let me zoom out. So this is where you would just write your if else statement, basically, and it makes a decision. True is one way, true, false will run this branch and true will run this branch. But in a GPT conditional node, your large language model makes a judgment and a decision. So it's almost going into that kind of the next generation of programming where you're going to have decision processes which are not absolute. They're not actually conditional in a pure sense. So there's some subjectivity to the decisions that a large language model will make, as opposed to traditional type decision processes. But anyway, so that's the this is the data block environment. And if I was going to show you what we mean by fractal data, I think I would go to this environment here. Tom, you may have seen this before. But so if I zoom in right here, what we're doing with fractal curriculum is we take a one parent node. Let me zoom out a little bit more. We'll take a parent node. Here was to be a parent node, and this represents 4 child nodes. And this is a child node, which represents 4 child nodes. And this is a child node, which represents 4 child nodes, right? So there's a fractal structure, which it lends itself to fast computation, lends itself to algorithmic traversal, and it goes very far. I mean, what you can do with fractal curriculum is crazy, like how far you can use it strategically. So when I say about fractal structures, this is just the fractal structure that we're using for our contextual, like main point, supporting details, theses, right? These types of contextual learning assets where and each red box represents a summary. So this is a summary lesson of 3 main lessons. This is an introduction or conclusion, which is a summary by definition of the 3 main points of the lesson. And this is a summary of the 3 main paragraphs right on that page. So when we're doing writing training, for example, we do writing training by summary. We start them by summarizing a full page, right? And then when they can summarize a full page, we have them summarize a full lesson. When they can summarize a full lesson, we have them summarize 3 lessons. And then at that point, they're pretty good writers. And remember that there is metadata behind everything. Like we have these essay builders where all of this structure is metadata behind the essay builder, so we can give them really good AI support coaching for when they write their essays. So the reason why I went in all that was not to go off on a side road, but to say that when you have fractally structured data, you can take it very far. That's my point. Now, the other point, it depends on what data you're bringing in. And this is a comment, Tom, that I made in our email, that this is informational text. That's why we're handling it this way. The assets that you sent us were not informational text, they were literary text. And I don't know what the fractal structure would be for that, but I would highly recommend thinking about that and choosing what kind of fractal structures you would want to generate with that data. And that would be a very fascinating project, actually. So is there any questions about this up to now, or is it kind of okay?
It's okay. Please continue.
It's okay so far? Okay. All right. So we did talk a little bit about well, you know what? Let me just go back to data block and show you how we generate this. Basically, we go first I'll go to maybe I'll go to excuse me. I'll go to GEC into our standards library. And I'll show you how this works from a platform perspective. So what we do initially is we'll go into our standards library, and it takes a minute to load because there are tens of thousands of standards in here right now, from elementary to middle school to high school to advanced placement to university, modern journals, and current research. So these are some of the, this is the vertical stack of low resolution elementary topics to very, very high resolution current research topics, right? So it's low resolution. Think of an inverted pyramid, right? Low resolution at the bottom, high resolution at the top, or would it be the other way? Yeah, anyway. So what the way these work, if we want to connect, this connects directly to data block. It's a different platform, but through the gateway, this is the API gateway where GEC is accessing data block, and anyone can access this service. Anyone, if they have access to this gateway. All right. So what we do then is we'll come into this. This is a grade and this is a subject, and we'll come right here and we'll say upload domain, and we can import a file here, and that file, once we import it and then we run this process, then what happens is it calls a data block service, and it runs the service in the background. And when it's done, it delivers formatted JSON back to here, and it creates domains and standards. So you can see in, let me go to a different, let me go just to life, for example. It has 106 domains in it. Let me refresh this. Oh, no, it didn't need to refresh. It was just calling the database there. So this is one domain with 4 standards in it, elementary stuff, right? And you can see the domains are green and the standards are blue there. So inside any one standard, you'll see that, excuse me, I'm having a little trouble with my frog. You'll see that we have 3 main points. Now, if you remember back to this view, there's 3, 1, 2, 3. Those are our 3 main points that I just showed you, right? So we assemble our lessons in 3 lesson sets, and then we do another AI process to summarize those lessons. So this is not built into our standards library, but all of these 3 are. So we AI generate these 3 lessons based on the standards, and then we have another AI process that generates the summary lesson off of these 3 lesson sets together. So again, how far can you go when you have structured data? Very far. This is actually a test as well. If I give this lesson to a student before they take these 3 lessons, that's a placement test. But if I give these 3 lessons to the students and then I give the summary lesson, that's a knowledge retention test, right? So each one of these little nodes is a quiz. Each one of these summary nodes is a quiz. So we have the testing built right in. Why? Because we have fractalized our curriculum. That's why we can do that. Okay. So let me just show you the process. I think I have a simple one that I prepared for you guys. I think I'm going to use this file parser. And I think I have a simple process right here. So this is a sandbox where we can test out our AI processes and make sure they're working well, right? And what I'm going to do is I'm just going to open up a folder here, and I think I'll just go into econ. Now this was what we did is we took a macroeconomics PDF. I don't know, are you familiar with OpenStax? Yeah, we just took an OpenStax PDF for this, and we converted it to Markdown, so this week. So we ingested it into data block and we parsed it. Let me just open with I think this is one that's been pretty well formed. So Visual Studio Code has a nice Markdown viewer as long as we say we trust it. Then we can grab this Markdown previewer here. Yep. So from the PDF, it extracted really nice structured data, right? So what we would, yeah, we got a latex error here. So, but no, we can actually use a large language model as we parse. We can tell it to write it in latex. Have you ever tried to write latex code? You scramble your noodles. It's not easy. But the AI, yeah. Anyway, now I didn't extract the images here, but we can. I didn't extract the image. This was just for Okay, so now that we can identify what our chunks are, but I'm just going to copy it out of here just to show you the data block process. I'll just take a couple of these. I guess the context window is about 4,000 input tokens right now, and 120,000 output tokens, something like that, right? But let me go to this process now. I know this looks strange because it's a chat window, but I'm just going to set that in here, and then we'll watch this response explorer. And what it's going to do, you see, is it's going to first get the key points. So here's the key points, and then it passes the key points over to the workflow, and then it's going to create the standards, the domains and standards. And we just got to wait for it for a second because it's thinking. I gave it a lot of text that it has to process. So this is the response explorer where you can actually see, this was the input data that I sent it, right? This is directly from that Markdown file. And this is the output. So it said, okay, it's making a heading and a subheading. And then under the subheading, it has key point 1, key point 2, right? It's pulling key points out basically. And when it's done, it'll change it into domains and standards. And it's hard to see here, but each domain has 3 standards. Each standard has 3 main points. Each main point has 3 sentences. It's fractal. So this is the fractal curriculum. And it just parsed it all out. And to see it in a usable environment, we would go, well, yeah, that's fine. We'll use wait a minute. I'm already on advanced placement. So yeah, macroeconomics, right? So here's that environment where, this is a domain, and here are the standards, and here are the 3 main points, and there are the 3 sentences, and I can interact now. My input language can be Japanese, my output language can be Korean. My input language can be English, my output language can be Japanese, right? And I can choose, here's my chat buffer, my conversation buffer. And what we're doing in here is that we can, when the student is conversing, we can evaluate their language and tell them how they're speaking language, and then when we choose this, this is part of the active content, and the chatbot will give coaching to the student about their language. But if we want to give an academic assessment and we change it over here, then here the guy is going to give them counsel about their academic knowledge. They say, you know, in our conversation, you showed that you didn't understand this. So let's make you a little bit less dumb and talk about that. You know, we also have the essay. So this is conversation, academic assessment, and language evaluation. This is essay evaluation and language evaluation, written knowledge evaluation and written language evaluation. You know, so this is one example of how we can do the interaction after we have structured these things in this way. And so again, here's your ontological stack: elementary, low resolution; current research, high resolution. And just to cover one more base, let's go back to where we were in this life. Remember, we looked at
explain too how the tutor remembers.
Yeah, so we do a sequence of nested buffers. So the conversation buffer saves 20 interactions. And every time you get a new 20, it summarizes that into a summary buffer. And so, you know, 20 entries into the summary buffer represents 400 entries in the conversation buffer. So you have a long range and short range context that the AI can remember from each individual student, from each individual user. You have to be logged in, but it'll remember and preserve your test outcomes. It will preserve your conversation outcomes. And so when you come back, it's persistent. It knows who you are. It knows where you're weak and where you're strong on every one of these standards. That's a good point, Perry. But what we've done now ontologically is that using our embeddings, we can say, oh, what are the topics at the higher resolution? You see, right now we're at elementary. These are the related topics at the middle school level, right? Demand curve functionality. This seems to be, it's going up to university. I started in, okay, wait, let me go back to elementary. I didn't click on the standard there. Life, bones, understanding the skeleton. This will take us to middle school. And it remembers like the one that it sent you to, so you can have a trail of breadcrumbs. But now I'm on bone formation. Let's see what we got in high school. Axial skeleton. Okay, so this is importance of the axial skeleton. Here's significance of pentadactyl limbs. Do we have anything? I don't think I mapped high school up yet. Oh no, we did. Okay, so this should go up to advanced placement. Advanced placement should go up to university, right? I think there's some nursing courses and stuff in the university level. So this is the ontological mapping, which I think I've gotten a little bit out of order, but down here from low resolution to high resolution ontological mapping, right? So we've talked a little bit about fractal data forms, about data block. The agentic development environment is extremely powerful. Then we did a summarization where I took a markdown file that we had parsed, and I just pasted it in there to demonstrate the production of these fractal structures. Then we took a look at the data interaction, where you can have user interactions that are beyond simple querying. And yeah, if I showed you what we have in GEC as far as lesson development off of these structures, yeah, it'd blow you away. Maybe we'll do that if we have time.
Well, Jeff, could you relate this to another element of their universe? So let's say that Tom now has those 100 books, and they've been fractalized into domains and into standards. Explain how now those 100 books relate to each other, so that when a student comes in for a specific topic, he doesn't have to look through the 100 books. But what's going to happen?
Yeah, that's number 6. And in order to talk about number 6, I have to do a bit of synthesis, I think, because Well, no, maybe I can do the synthesis while I talk about it. But I guess the one thing I would say is that for what I'm saying for ontological foundations, basically, is that these research papers are best if they're sitting on top of a foundation. So if you're going to do very rich embeddings structures to make your search and your resource, I'm to make this as useful as possible, right, to a user. It's going to be best if it's sitting on top of these lower level structures, right? If we were to just fractalize these at a high level and without any foundations under them, yeah, it's going to be powerful because you're going to be able to do all your beddings, all your ontological relationships, everything. You're going to be able to do that. But can you see what I mean by it's much more powerful if all of these lower levels are undergirding or they're foundational to this modern research. And so now you can go up, like if I'm in a research paper and there's something I don't know and I can drill down and I can find, oh, right here at this level, it gives me what, no, actually, I don't even understand it at this level. I got to go down one more and then up, up, up. Okay, now I know, right? You see what I mean? So having your research based on this foundation, I think, could be a critical strategy when you're building out, when you're conceiving your final product.
The knowledge is always developmental like that. So to me, this is essential for research.
Well, that's what we're doing. I mean, we're already doing some research papers, but honestly, we've been really busy down here. We're just starting to move up into here, starting to. Yeah, we haven't really gotten much into this level yet, but it would be wonderful to work with you guys. Because with your asset base, man, we could create something really special, I think. Yeah. Okay, but anyway, that was a precursor a little bit, sort of to talk about what I mean by recursive auto refactoring, and I drew some little schematics here. This thing it got so huge that I had to make a new. It took too long to load, so I had to start a new one. This is my new one. All right, so down here,
Hello, Kwan.
do we have another member?
Yes.
Okay. Okay, so this looks a little bit. This might look familiar. Does this look familiar to anybody? Some of these. This is vectorization going on here. But before I talk about these two colored ones, I want to zoom into a simplified version and just talk for a minute. So at the top here on this top row, I've got image, video, audio, and text. Now, I just put this up here so we can conceptualize something. Like if you have an image, can you create text from an image? Yeah. Yeah, they have vision empowered models, so you could. Can you create audio from an image? Not directly, but through the text you can. And if you have image, text, and audio, can you create a video? Yeah, you can. Likewise, if you had a video, can you extract the audio? Yeah. Can you create the text? Yeah. Can you take frames to create images? Yeah, you could. So these are components like image, audio, and text are all components for a video. Can you create? Yeah, it's the same thing, right? You see where I'm going with this. So what we're thinking of is that with any block of text, these are the other assets that can be associated with. And of course, all you're doing is creating a set of embeddings that have more than one asset type, right? Because the images can be all related to the text. The video could be related to the audio, right? You could have an outside web source, which is related. You can have user-generated data, which is related to this. And so we're talking about, basically, well, let me actually show you an example over here. Inside, let me go to just this high school course on being a pilot, aeronautics for flight training and aircraft structure. So this is I'm logged in as super admin, so I can edit these. But right here it was the one of the images that was extracted when we pulled that. When we pulled the text out, we also pulled the images out, right? And we didn't have to come. We can come in here and edit this. We can come in here and put a link, but that's not what we did here. Through the embeddings, it knew that image belonged with this text, and it automatically structured that from the raw data. It extracted and structured it by itself from the raw data. Okay, so this is a now we obviously didn't have any audio or video from that PDF. But let's say that in that PDF, there was references in this section that had a link to a YouTube video. We could have extracted that and put that YouTube video link in here as well, or a Wikipedia article, or whatever the reference was in that PDF. We could have pulled that reference and we could have made it a component of this cluster. Basically, it's an embeddings cluster, right? Now you can also run processes where we can just do web search and say, okay, I have a web crawler that I want to go out, and it's going to find other references for me about you know about this image, or I guess there's a better one about fuselage design, right? You've got this Warren truss. So maybe we say, well, we want to collect more outside information about the Warren truss. We can have automatic bots running around looking for outside assets that we can attach into that embedding cluster, so that there's a lot of reference material for this, right? And so that was my point in talking about all of this, right? So we're trying to create these clusters of assets. It's not just text, right? And it all is part of the embedding structure. So down here, you'll see this blue one is kind of colored blue, and this red one is colored red because we've got some red stuff going on here too. So there's a relationship. This is a simplified discussion of what's going on down here. So let me just stop for a minute and ask if there's any questions or anything before I go on. Do you guys have any input or any questions?
Yeah.
No, it's okay.
I'd like to
Yeah,
ask, how
Jeff.
much time do we have left? Do we have another half hour?
Yeah, we are we have free time. You can
Okay.
proceed.
Perfect.
Yeah, Jeff, I
Okay.
actually have a question. Yeah, regarding the data block AI you just showing, is that the solution that developed by your company, or that's the service that there is some
Yeah,
others? Yeah.
yeah, that's all homegrown. So Data Block itself, the platform, we created that, and then we just created the social media automation as a kind of a project to test out how powerful it was. Yeah.
Yeah, to
Good,
me, it
good.
looks a little bit like a lane graph, the concept, the workflow, which for you to organize how you process the data. Yeah, and I'm curious that the content by utilize the data block to after processing, it could generate a lot of specific topic, and it's supposed to based on the set of the content instead of just one single book. Is that the understanding correct?
Can you just repeat that one more time? I'm sorry. Let me turn my volume up a little bit.
Yeah. Yeah, I mean, for the system to ingest the data that we provided, for example, if we have a set of data relate to the nursing, should the system to process all those data all at once to generate all those topics, subject, all those information, or it should be processed like one by one to generate the information specific for these books? What is supposed to work?
Yeah, that's a good question. So it's kind of both. Do you remember when we were looking at this? It did this one first, and then it did this one.
Yes.
If we had here, I'll show you one, for example, just to answer your question. Here in this, I think it's in here. Okay, can you see the size of this? So here's one AI process, and here's another one, and here's another one, and here's a join node, and then here's a branch node. So So we've joined all of these three processes into here, and then we're passing it into a branch node, and we're processing all of this here and here at the same time, two different processes running at the same time, which passes back into here, and then it has to format the JSON because, yeah, because GEC has to accept it. So this is one process, Art, but these are different processes, right?
Okay.
So that's what, and if you were to go to a different module, if you were to build another module, and that module was to reach back to here to do something, and it's doing, and you have three modules and they're all working together, five modules, then you press one button and everything happens. And to you, it looks like one thing, but the data block is like, and it's busy in the background doing many things, right? Does that answer your question?
Yes, I also like to know that, for the system to create the information like what you show, is that the content that we provided needs to be like reach to a certain amount, maybe like 100 books, yeah, or maybe just one book you can create sufficient information to be provided.
Well, that question is, there are factors, right? So the first thing,
Yeah, fracture,
it,
yeah.
well, like for example, if you're using large language models to do summarization or to process and structure that data, there are context windows, which means you have to define your block size. Like how much of a chunk are you going to feed? How much of a chunk are you going to process at one time? Let me give you a better answer. So let me zoom out and I'll show you what I mean. Um, so this blue area, this is what's happening inside data block, right? And this is probably a process which is common to you because you ingest a PDF, for example, and then what happens, actually, I should go over here because this is a better representation of it without interruption. So basically, that PDF is going to be ingested and then it's going to be broken into chunks. And like for example, I don't know if you've ever used like Llama Index or Llama Parse or anything. It
Yes.
it breaks it into chunks. It calls them documents, basically. Llama Parse calls them documents, and then it atomizes them. And it's through this atomization. And like one node could be an image, another node could be a text, right? And the embeddings, and then the embeddings happen based on their proximity relationships. And then once the embeddings are done, it spins up a vector database like Pinecone or something, and then you can query it. So your question relates to this, like for us, we do a lot of processing with large language models. So before we vectorize, we'll take that chunk and we'll send it to another process inside DataBlock to create our fractal structures, right? And this gets saved in a relational database here. But then we continue with the raw information because we want that high fidelity version of the data because this is summarized version. This is not high fidelity, right?
Sorry. One question about so if a new article is coming, so the relationship will recalculate again.
That's what I want to talk to you about. That was this.
Oh, sorry.
No, you're right on the same page, right? Right here, this recursive
Yeah.
auto refactoring. That's what you just asked about. So
Mhm.
yeah, your brain is on fire. Thank you for that. But Art, before we talk about this, I just want to make sure that answered your question.
Yes, yeah. Yeah, because I think we probably won't let like a meaning of the book to be ingest. Instead, we should select a certain topic for the system, maybe a bunch of data for the system could be, processed.
Well, actually, you can dump a 2,000 page PDF in here, and it will chunk it, and
Okay.
then you can save the chunks. And you can
Mhm.
actually define what you want you can define what delimiters you want it to chunk upon. Like by default, a lot of them will just go and chunk by page. Like if you have 1,000 page PDF, it's going to give you 1,000 chunks because it does just one page at a time. But let's say that you say, well, wait a minute, I don't want to delimit based on the page. I want to look for chapters. So then, then we have to look at the markdown. We have to see if it's a markdown that we're converting to, right? And we have to see, okay, there's going to be 2 hashtags and the word chapter. When we see that, that's our delimiter, and we'll chunk based on chapters instead of based on pages, right? So we can do that kind of thing. But like, let me give you an example of a difference. If you were going to loop through the chunks and use a loop and do something procedural instead of with the large language model, you could process a lot more of these at one time than you could with the large language model, because your large language model has a context window, for one thing. And for another thing, if you feed those LLMs too much material, they get really stupid. They there's this sweet spot for how much you can give them before they get dumb, and every large language model is different. So like if you use like a meta model, it's going to perform a little bit differently on a certain task than one of these commercial models like Grok or OpenAI. So that's why that development sandbox and data block is so important, because you can explore the output, and if you're not satisfied, you go back to work, you change your model, you change your prompts, you change your chunk size, right, until you get it exactly like you want it. And it's custom for each. It can be custom for each type of a project. Like
Yeah.
if you were. Mhm.
You've touched on something that perhaps is common to all of you techie guys, but it isn't to me. But the notion of AI is often looked at as large language models and nothing else. But what you just described is there's many contexts of AI, and language models are just one of those.
Yeah, large language models are a manifestation of fast computation and and scientific engineering, basically. So
But
like, for
you
example,
but you just introduced other models that you use that are more efficient for some processes than those ones, but they're still AI.
yeah, embeddings are not large language models, but they use machine learning.
But I think that's important because oftentimes when we're talking about the world of AI, we're just talking about large language models when actually there's a lot more to AI than large language models.
Yeah. Yeah, actually, but there's a lot of work being done in engineering. Like, for example, if you look at like vortex, like Kármán vortexes around a fluid flow or around a cylinder, highly dynamical chaos. It's basically a chaotic system, and they're discovering ways now, because we have the fast computation, massive, massive, to actually predict those types of systems, right? Using fast Fourier transforms, using principal component analysis, and these. So that's the real interest for data scientists. It's not large language model. Large language models are just a manifestation of that science, where the underlying science is much more interesting, actually. Yeah. Okay, but that's a good point, Perry. But Art, did we get to the core of your question?
Yeah, thank you.
Yeah.
Thank you.
Okay, so then back to what you were saying then about this recursive search. So I'm kind of showing 2 different representations here. This representation is this bottom blue section, and this representation right here is this red section. So like what we were doing before is we would vectorize material, and we would vectorize we would ingest a PDF, we would chunk it, we would atomize it, we would embed it, and then we would spin up a persistent, Pinecone or some vector database. And then we would take the chunks before we processed them, and we would run these through our fractal curriculum processor. So now you have a summarized version of the PDF, and you have also a vectorized version of the PDF. And what's interesting about that is that this version is summarized. That means it's lower accuracy, right? It has lower accuracy than this one does because this is the main one, but it has higher it 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 has higher fidelity. No, I'm sorry. This has higher fidelity. This has lower fidelity. This has higher accuracy. This has lower accuracy. So I've refined this to be highly accurate, but this is unstructured, but this is structured. You see what I mean? So the question now is, how do I confirm? How do I get high fidelity and high accuracy? That's why I have this. I want to reference back to the to the high fidelity version so that I can refactor this, so that I can refactor my make sure I can double check on my accurate version that it also has retained fidelity. Now, what's going on here though is I'm running another process I'm creating lessons. So what that means is that the AI process that ran here is secondary to the AI process that ran here, which is secondary to the AI process that ran here. So if this is high fidelity, this is mid fidelity, then this is going to be low fidelity. So I also want to reference back to my high fidelity version in order to in order to confirm this. So that's what I mean by recursive, right? It's like recursive. So let me zoom in and just confirm that.
So they're learning from each other.
Well, they're referencing back to each other and they're refactoring their embedding structures by cross-referencing to themselves. And what's interesting about this is you have a relational database that has not been vectorized. There's no vector version of this structured data. But over here, we've made a change, you see? What we're still doing the entire blue process. But what I did is I chopped off the blue process at the chunks. Then over here, we're going to use data block to structure and a large language model to structure fractal curriculum. And then we're going to vectorize that. And now we have a vectorized version and a structured version of this, this lower fidelity version. And we have a unstructured version of the high fidelity one. And what that means is these are decoupled, right? Like the structured version is actually decoupled from the vector version. So whatever the changes that happen over here as this references back to the original, because like this vector database will reference back to this vector database and it will restructure itself based on the high fidelity version. And then I can back structure that. See what I mean? So the fact that these are decoupled means that I can update this before I update this, so I don't lose my persistent state. See what I mean? And this is a really cool process because now if you think of that in the context of this environment, yeah. Every time you add new material, you just have an automatic process that runs in the background and everything is secured and everything is updating all the time with your embeddings are always updating. Right. So now your traversal up and down and diagonally, you can go in diagonal. What I mean by horizontal, okay, so these are vertical, right? I mean, we're going vertically up the stack from elementary to middle school to high school to advanced, all the way up to research. But think about horizontal connections because, like, for example, in elementary topics, I have, well, let me go to middle school topics. I have life science and earth science. So if I'm studying earth science and it's talking about like biomes or something, there's going to be horizontal connection over to life science because there's a lot of connectivity between earth science and life science actually. So that's horizontal embedding connection, but going from foundational up to high school is vertical, right? So what we do is we establish the vertical, relations first, and then we establish the horizontal relations second, and then we, by definition, we also have developed the diagonal relationships, and all of that is critical to having this refactoring, like this recursive refactoring, right?
Jeff,
So
could you reformulate what you've just told us in the context of now a teacher wants to develop lesson plans, use the database of these millions of books, and press a button to have it done for them rather than all the research it takes to put that outline together, the syllabus together, or whatever? How do they use this in an efficient way where this becomes their lifeline?
okay, so I'll show you that, but I'll also show you an extension to that too. So first of all, let me zoom out. I'm going to go back out pretty far and up to here. I've got another image up here. I think it's right here, this one. So what Perry was talking about is an automatic lesson generation system that we've built into our global English campus that also reaches back to DataBlock. So let me just jump back to here again. You see where we can auto generate derivative assets. All right, so we have this like this data set now. And what can we do with that? One thing we can do is we can interact with it, right? But the other thing we can do is generate derivative assets from that. And so what we're doing right here is we're creating the fractal structures, and then we create lesson groups, domains and standards, thesis statements, and main points. This is all part of what's created from DataBlock. And it's built into our lesson, it's built into our standards library. Step two, then we reach back to that again, and we create JSON lessons text, JSON text from DataBlock. And we bring from DataBlock back into GEC. We select the keywords, the phrases from the paragraphs. That's an AI process. And it actually generates all the audio with AI. It generates all the images for the lesson by AI. And then it generates all the different level versions, because we'll create an syntax level at A1, A2, B1, B2, right? So maybe we'll create those 4 versions of the same lesson. Then we'll create a different language version, like a Japanese and a Taiwanese and maybe a Burmese version of that same lesson. And when that's all done, then the students will study on it. We'll put that lesson into activation where the students are now studying on it, and we get students who are performing suboptimally, and we get students who are performing optimally. We measure the variance between the performance, and then we revise. We automatically revise our lessons. And the reason why it was so important for us to make this a one-click operation is because you can't it's much easier to automate something that's a one-click than it is if you have to have a lot of human intervention at every step. So Perry, I just took your question one step farther. But again, the only reason we can do this is because the data is fractal. Like, again, how far can you go with your data? It depends on how well you've structured your data.
Well, describe too how question generation takes place within this whole context.
Okay, so that would require me to go into the platform, but what I'm going to show you is this. Step 1, step 2, step 3, step 4, I'm going to show you these. So just keep in your brain that where we're coming from, because we're jumping around a lot. So inside the GEC platform, I showed you this is the standards library, right? These we call them curriculum libraries. And inside each curriculum library is both a standards library and a course library.
You just hold it one minute. I wanted you to tell them how their IP is protected through what you're just showing us.
Yeah, these are separate libraries. Like this here is a customer in Japan who has, it's a purely IP protected and it's siloed. So like you have to give permissions, you have to give permissions for which user hierarchy can use this library. So, right. So it's protected. We just spin up another library for another customer, and all of their stuff is separate. And so like for a user, if I had a partnership with these guys and they wanted to use my stuff and I wanted to use their stuff, then we would have some district level users that had access to both libraries, right? So we have that capability. Does that answer your question, Perry?
Yeah, well, I wanted them to know they would have an iGroup library. That's theirs. We don't own that. That's theirs.
Yeah, one or more, however you want. Okay, any questions about that, or should I move on?
Please go ahead.
It's okay to move on? Okay. All right. So this is our main curriculum library, and the standards library and the course library are children's of this, obviously, right? Of this curriculum library. And these are connected. And so let me show you what I mean. So like if I go into the course library, and I want to create a new course, I have to connect it. I have to connect it to, right? Here's advanced placement, which was in the standards library. And from advanced placement, I can choose among these items as far as which standards I want to be related to this course. So they're connected. Okay. Now, once they're connected, then when I want to go in here and actually create a lesson, then I'm going to do it. I can just say, okay, well, this is, whoops, I don't want to add a file. I actually want to name it. So this is I grew by, wait a minute, my fingers are too fat. iGroup demo. Anybody else have fat fingers? Okay, so anyway, from here, I have to actually choose which domain I wanna use. Let's take potential and kinetic free and activation energy here. I'm going to require 75% pass rate, and I'm going to create this lesson. So now I'll have a new lesson in here, the iGroup lesson. And what I can do is I can say, generate a curriculum builder lesson. And I know I only put one domain in here. I could put more than one domain, but I just put one. And here are all the standards involved in this domain. Now, this is fractal. These are our fractal data. And let's do androgenic reactions and exrogenic reactions. Let's do that. Okay, look at that. This is our sentence 1, sentence 2, sentence 3, right? Main point 1, main point 2, main point 3. So this is the now I can add assets in here too if I want, images or audio or whatever. But when I generate the JSON, it's making a call to data block. And data block is actually, it's going in through that through that gateway node. And it's a data block is doing that huge process. It's doing like 17 different AI processes. It's right now it's doing that. But for me, it was one click, right, Art? Back to your earlier question. One click, and I'm like, woohoo, go get a coffee.
Yeah.
And it's going to take, 3 minutes. And when it's done, I will be able to explore the JSON down here. And before I actually create the lesson. So to your point, Perry, we don't normally give teachers these superpowers because their heads explode and they're not interested. But we can. We can give them, and they can generate any lesson on anything they want. Right, because with more than 30,000 different standards, we don't obviously have not created full lessons for every one of those standards. Right, so while this is going on, let me actually show you what one of these looks like when they're completed, when the whole process is complete. So this is part of our rapid curriculum generation system here, and I'm actually going to probably go to like page 40 or something to make sure that there's one that's completed. Canada, Alaska, and wild wilderness. Yep. So this would be the A1 version. Why do Canada and Alaska have fewer people? This is the B2 version. What are the reasons behind the low population density in Canada and Alaska, right? So it created these 4 versions. It created these 5 pages. And of course, there's an essay builder that I have a publish mode and an edit mode. So if I want to choose images from the, for my essay, I can. And it generates all of that. Let's see if it did the JSON yet. Oh yeah, there's our JSON. So this just came back from DataBlock, and I want to check to see if I have everything. Okay, I got paragraph 1, paragraph 2, paragraph 3. They each have a main question and a single sentence answer, and they each have 3 distractor answers. And each page has 2 discussion questions. That's exactly what we wanted to build, right? So that's going to be here's a thesis and a general statement. So it just generated it from the standards. And this is a lot of content, right? So this is what we're doing here is we're taking these 3 standards and we're expanding them into a more detailed treatment of those standards. There's other ways that we can do this too. Like we can take 3 standards and give a standard, give a basic treatment, or we can take 1 standard and expand it. Like there's different ways to do this. But here's all the data. So I'm going to say there's nothing missing. So I'm just going to go ahead and generate that. Whoop. DQ1 is an undefined. I think it missed the discussion questions here. Sometimes, like 1 time out of 10, the AI will screw up and you have to run it again 1 time out of 10. But I think I can simply put those in there. Yeah. I cheated. Sorry. And then when I go back to the curriculum builder, oh, look, there's the iGroup demo. And here's here's everything without images. And what we would do now is just go here. Now we can do this 1 by 1, or we can click this. And if you click this, it creates 360 problems, creates all the images, creates all the different A1, A2, B1, B2 versions. If you want to create A2, B1, B2, and C1, you just change a couple settings before you run it. Yeah, and it'll create 4 different versions. If you want to create an alt language version, you can translate it to whatever language, right? And save it in whatever, you can save it in the Vietnamese library and you can translate it to Vietnamese and it will translate the whole thing. And now it's a pure Vietnamese learning experience right now. Okay, so, but I didn't run all the image generation on, oh, you know what? The other thing that is really cool, let me actually, let me do this. I'm just going to do 1. I'm just going to do the word generation. So let me describe to you what's going to happen here. When I do the word generation, the AI is going to look at all of these and it's going to say, well, okay, what maybe external input is a word that we want the student to practice. So it's gonna mark that word and it's going to check in our dictionary to see if external input is in the dictionary. If it isn't, it's going to create it. It's going to create an image for it, and it's going to put it right here for us. It's crazy. So let me actually, okay. And then from the image library, if you click this, you have access to the full translation of everything, right? And this is all AI generated stuff. It's amazing. So let me show you how that works. It's so impressive. Sorry, I just got to do the word generation here. Okay, so it's beginning, synchronizing, and what we can do, I think, is just go to the image library and watch it happen real time. So here in the image library, takes it a minute to load. Shouldn't take that long. Oh, there we go. Okay, so as it does its process here, I should be able to refresh this, and we'll see when it finds one that's not already in the image library. Okay, so it's done page 1. It's going to jump to page 2, page 3, page 4, and page 5. Yeah, 20% at a time. But refresh this now. We might see one that was not already in the image library. Oh, there we go. Look, exogenous reactions. So what it did is it has the
exergonic reactions,
and then it has 2 synonyms.
energy releasing reactions, spontaneous reactions.
Then it has 2 antonyms.
Endergonic reactions, energy absorbing reactions.
Then it has a definition sentence.
Exergonic reactions are chemical reactions that release energy.
Then it has an example sentence.
When wood burns, it goes through an exergonic reaction and gives off heat and light.
Then it has 2 wrong answers. It has 2 wrong definitions, and it has 2 wrong example sentences because we use these for our automated vocabulary lessons, because it spins up a vocabulary lesson also. And at the same time, what it's also done is it's gone ahead and translated all those assets have now also been translated into the languages that we define. And it does like 14 of these every sec or every minute. Now, if I had one of my curriculum guys do it, it would take them 20 minutes. It would take, well, you got the translations too, so it'd take them 45 minutes to do one of them. But the AI is doing 14 of them in a minute. So our curriculum guys are doing higher level things these days, actually. But
One of the things that was so impressive to me, Jeff, is when you showed me how our system can create videos from the lesson on the topics. I was just blown away.
Yeah, here's Happen on Their Own, energy gifts. So it's picking out some not single word targets, it's actually phrasal targets, which is really good for our students, Yeah, but a good point, Perry. So those will show up someplace. Do I have it open? No. So those words as they come on, we should be seeing, yep, look at there. They've shown up here, and now it's still, oh, look, we got an image. The first AI image that has appeared. The images take longer, right? Okay, so that's an example of what Perry was talking about here, where, oh, actually, let me show you one more thing on that, because not on this one, but well, not on this one either. Okay, wait.
Well, Jeff, you showed us the ebook version. Can you jump from there into an actual question where they can see how those two things toggle?
Yeah. So I'll do that. Let me open up the edit environment. So you can come in and edit all this as a human. We very seldom do. But what's going on down here is that we have reading questions, listening questions, or writing questions, and speaking questions. And we've got both prompted writing and open-ended writing, and we've got prompted speaking and open-ended speaking. So it automatically creates 6 different questions for each paragraph. So here's paragraph 2, 6 different questions. Here's paragraph 3, 6 different questions. And what it's doing right now, what the AI does, is it comes in and it looks like this has not been processed completely, this lesson. We have lessons in varying stages of completion. But what it'll do is it'll come in here and put asterisks around here, and those are the words that it'll create, right? Like if I click this generated words, it's going to run an AI process to it's going to run an AI process to select the words out of here. That's what the AI is doing, how it's doing it. But yeah, so these are all generated automatically by the AI. So 15 questions in one book, that's 90. 15 times 6, that's 90 questions. But remember, there are 4 language level versions, so that's 360 questions per lesson. And this is part of our adaptive system. Did I just close that? So what Perry wanted me to show you is this environment here. I don't remember what page. Was it page 40 I went to? That same lesson. Yeah. So if I click here, whoops, I've got 18. So that yeah, this won't work because you have to have 15 each for the skills. What is called is like we call it weakest skill. Yeah. So we've got to delete 2 of these. But anyway, here's the group for you, right? So here you've got question 1 has 1, 2, 3, 4, 5, 6 versions. Okay. So if I click in and I want to view this, and remember this one also has 6 A1 versions, 6 A2 versions, 6 B1 versions, and 6 B2 versions. So if you look at the preview, right, you've got the.
Can you identify some of the various landforms that can be found across the United States? The United States has a highly.
And then the ebook is available inside the lesson environment. And here's one of the AI videos that Perry was talking about. I could probably play that from here, maybe. Oh, there it is. This is the admin side. It's kind of clunky in here as compared to the. Can you hear that?
Cannot.
Can you name different types of land in the USA? The USA has many different types of land, offering a variety of landscapes. There are mountains, flatlands, deserts, forests, and swamps spread throughout the country. Each region has its own unique features.
Okay, so we're using we're using a series of different AI tools to create this, right? We're automatically selecting clip footage. You know, we're also using LipGAN for the lady to talk, right? And then we're using text generation to create the the context. So this is multimodal video generation going on in here. But yeah, so that's the lesson environment. Each problem, this is actually at the B2. This is a B2 version, so it has a language level indicator. There's a problem statement where in the student lab you have an AI tutor, and he talks to the student in this environment. But then if you go to the actual question environment, then the AI won't tell you the answer in here. But when you're done and you submit, you get the feedback where the AI will actually explain to the student like what they got right or what they got wrong and that kind of thing. So yeah. So Perry, that was back to your point about what we can do further with that structured data once we have it. And I think for you guys, you probably in many cases would not want to do what we did, but you would want to define your own processes and your own outcomes and your own eventualities, and we would just help you to craft the whole pipeline to get, and you might have business records that you want to handle in one way. You might have research papers that you want to handle in another way. You might have literary works that you want to handle in another way. And for each one of those cases, we would just create the pipeline. And then for every asset that fits that category, you just throw it in the pipeline like that.
Excuse me. We sent some PDF, and do you have a chance to do something with that PDF, even though some books are not good? Can you?
I did.
Demo?
I did. Let's see, where did I save it? I think one of my comments on the email was that what I don't know what kind of summary to do out of it. So I did here was one of the extractions. I do have that. Let me show you the extraction, and then we'll just run it. We'll just run it together then. I did it yesterday, but I'm not sure where I saved it. I think it's this one. Okay, so this is how the this is how the data came out when I just pulled an extraction to text. Okay, so this is the wide world. This is one of them. It was in English. I think there's only a couple that were in English, and then you can see this has a text that I can grab. So without delimiting anything, just by grabbing well, let's just go to like chapter. Let's just pick it up to a certain chapter. Breaking the news. You see a chapter 2 anywhere? It should be easy to see. Oh, still breaking the news. Like what I would do is I would come in here and I would find that I would chunk it by chapters, right? Anyway, this is getting to be probably a lot of text. So let me just pull back to here. We'll just copy all that text and we'll throw it into data block, and but I'm just going to use that same fractalization that we use for our lessons, because I don't know what kind of data structures that you want out of this. Like I would. So again, if we go to I think it was this one, wasn't it? And probably probably use this one, and I'll just pop this in here, and we'll get data out. I did it already. I'm not sure where I saved it though. So I just dumped the data raw in there. I didn't do any cleaning of anything either. I just dumped it in, and we got key points already. See what it does with it. But
I'm
what
not
we
seeing your screen.
oh. Okay, so then back to this. So this is the data that we extracted. So you can see it's kind of messy a little bit, right? It's unstructured. So I didn't do it into Markdown. I just dumped it into a text file. And then what I've done is I copied this much of it, and I just pasted it into data block. And we've got standards now. So let me actually just copy this all out of here. This is how it processed it according to our fractal curriculum structure. That's what I was saying. I don't know like what kind of structure that you'd want out of this, but maybe I can open up another notepad and paste it in here. So you've got main point. Well, you've got should have done it in JSON so that it would already be structured. So there's a standard, main point 1, sentence 1, sentence 2, and sentence 3, main point 2. And then there's sentence 1, sentence 2, and sentence 3. And then there's main point 3, sentence 1, sentence 2, and sentence 3. And then there's standard 2. Remember, there's 3 standards per domain. So it's saying that, okay, there's initial inquiry. Ellen's curiosity about the lawsuit puts her in a challenging position. She feels a responsibility to understand the situation, but is met with her mother's reluctance. This deferral suggests a deeper emotional layer that is difficult to navigate at the moment. So that's how our process is parsing that. So let's take a look at the original book, which I think I still have it. Should be a WeChat in here someplace. Yeah, right there. I think, was it this one? Nope. Was it this one? Yes. No. Yes. The wide world. This is it. So it's obviously jumped over all of this stuff and gone directly to the first chapter. So it says here, Mama, what was it? What was that I heard Papa saying to you this morning about his lawsuit? I cannot tell you just now. Ellen picked up her shawl and spread it out over me. Mama, you are cold in this warm room. Are you cold in this warm room? A little, there that will do it. Now, my daughter, let me get quiet and don't disturb me. There was no one else in the room. So like you can, it actually would be very interesting to go. I did actually, when I did this before with the other one, I went through and looked at Ellen's curiosity about the lawsuit. So there's probably going to be a lawsuit in here someplace, right? But I mean, to analyze this, you'd have to spend some time just kind of looking to see the output. So what I'll do, let me do this, okay? I will go ahead and format this, and then I will send it to you in a zip file. Tom, we still have a Skype, right?
Yeah. Yes, we got.
Okay, so I'll zip the output along with the extracted text file along with the processed output. And I'll put this PDF and those other 2 files into that zip file and send it to you, and you guys can take a look.
Okay.
Okay?
Yeah.
All right. So my lips are blue.
But Jeff, what you're saying or implying is even though they will see this in a text format, if it were in our fractal LMS and in their library, they would see it in the context of our
Yeah.
on the student side, they would see it as the advisor. And on the teacher side, they could see it as lessons.
Well, what we would do with this, if we had permission, is that we would just generate lessons out of those fractal structures.
Yeah, it will be nice so that we can see the output.
Oh,
Yeah.
Okay, yeah, no problem. We'll make a couple lessons out of this. That'd be cool.
Yeah, just a few example so
Yeah.
that we can see that text you send to us and compare how it would create and become, and so I can also explain to Mr. Lee also
Okay.
your actually it's amazing technology. All are speechless. You done great thing, especially that data block that we are very much a lot to learn, and also a really great platform. And so thank you very much for your time.
Yeah, thank you for your kind words. Yeah. Yeah, we sure use data block a lot. It's very useful.
Yeah, very
By the
interesting.
way,
And yeah.
oh, go ahead, go ahead.
So especially the ID engineers will be very much interested. And that's why Art is asking some questions. And we have a lot of knowledge from your demo today, and how you very much detailed development. And do you have a team for Jeff? Do you have a team of
Yeah.
developers?
Yeah, we have we have three master's degree machine learning guys, and then all of our back end, front end developers and curriculum guys. Yeah, it's quite a
Good.
About 14 altogether, isn't it?
Yeah, it was more, but we've been getting more efficient with the advancing tools, right? So like even coding is a lot easier now than it was 2 years ago, right? So
Yeah, Dr. Ma, he's now threatening to replace me by AI. So
Yeah, my
I think
team is also trying that way.
we're a long way from it.
Soon we don't have a job to
I
take
will
care of them.
I'll be a victim of Doge.
Yeah, well, I mean, I'll tell you what, Dr. Ong, I think there are going to be innovators still in the game, and everybody else is going to be on universal income.
May I know what kind of models you are using in these system, LLM models?
Yeah, are you familiar with Open Router?
I see.
They have all of those different LLMs there, but we're
Show
also
him the page where the list is, Jeff, where he can see that. Do you have that handy?
yeah. Yeah, I'll give you a little insight into our AI development environment. Really quick. So back to GEC again. It's the easiest place to see it. We have a couple of things going on down here. This is the old AI IDE before we build data block, but we still use it for simple stuff. It's extremely powerful. But so we can pull on. Well, this is you might recognize this. This is a Vantage learning model, right? Redshift. So we can put any kinds of machine learning model, prediction model, classification model, large language model, anything we want in here, and choose which one we're going to use. And then we have a Jupyter Hub running. See if I'm even logged in. Where okay, so like for example, well, let's see, here's one that I was using, the SVD cat JPEG, right? So I was running a sync value decomposition to see how many values that it would take to represent this cat image. Out of 532, this is using the first R truncated 10, and this one is using the first R truncated 20. So it's I just use this sometimes to illustrate to the guys how we can do data reduction and still get good analysis, of the data. But we use this and we'll generate models out of here, which we actually use in here, right? So yeah, we can blend, and that's in data block too. You don't have to be just using obviously large language models to Perry's earlier point. If you want to do large language models and then do some prediction, some classification, or some other type of process, and then take that output and throw it to another model, right? All of that we can do in that one environment. So it's pretty powerful.
You have DeepSeek in here too, do you not?
Yeah, DeepSeek is free right now, and it's pretty good. So I think it's still free. Open router.
Just so you know, I had a message from David that he apologized that he couldn't join. He was in a meeting.
I see. I think they are together with the Mr. Lee. I think Mr. Lee just called me and asked us to proceed.
Okay. Please give our greetings to him.
Yeah, look at that. DeepSeek is still free on Open Router, so we're making use
Tell
of that.
him I'm looking forward to my next durian feed with him.
That's good. Okay. Okay, thank you very much. And another one question, with your experience, you are using different models of LLM, and do you need to, over the period, do you need to encounter to train yourself for any models necessary?
Sometimes, but we've tried a couple of things have happened. That's a really good question, Dr. Ong. So first of all, initially we were training, especially when we only had access to GPT-2 and GPT-3. But the new version would come out and all of that training we would throw out and do with the new version again. And we did because GPT-3 was not really that great. So the training was it was still from a cost benefit perspective, it was still worth it to do that. But when you start getting into these new language models, there's less need for that unless it's really specialized. But one way that we accommodate that, like for example, I'll tell you, when we were testing, remember I was showing you that GPT conditional node where it was having to make a choice?
Yes.
Actually, the coding models do better at that than the pure, language models do. And we had to experiment around with that. So it's become more like that now. Rather than doing a lot of fine tuning, we just search around to test different models to see which one works best for a certain
I see.
process.
It's
Not
a
all
good.
the time, but that works most of the time. And I think it's going to continue to get better to where there's less fine tuning that will be. That's my
Jeff,
instinct.
what percent would you say you use a machine learning models versus large language models?
We'll use machine learning models. Okay, so we use the AI a lot for curriculum generation, which we just well, probably if we were doing statistics or like high order algebra or calculus, we might want to use more custom models to guide things. But when it's just literary stuff, which is what we focused on because we're mostly English training right now, then we just use the large language models for curriculum generation. And then for student interactions, still we're mostly using large language models. But when it comes to data analytics and like with student analytics, performance analytics and stuff like that, that's when we're going to start using some more, traditional machine learning more than the LLMs.
Well, I wanted to comment on that, Jeff, and you know better than I. When people are talking about AI, they aren't really talking about machine learning models. They're really talking about large language models. And that's where I think we have the strength of mixing whatever models it takes to mix them all together in data block to get something better than what others can do.
Barry, you're making a good point, and I'll show you where my brain is about that. I think I still have these open here. I want to go here again, and I want to go two places. One place is right there. I think I missed it. Oh yeah, right here. So I want to go right here. So what we're really trying to do is basically the science of learning, right? So this looks complicated, but it isn't really. Like you got microdata, metadata, and macrodata that are rising mostly from student activity on the platform, right? And so microdata is going to be in the moment. It's going to be formative. You clickstream data, 1,000 data point per hour or whatever. Metadata is going to be 2 weeks or a month, right? Where we're not looking at effective states in the moment anymore. We're looking at effective constraints. We're looking at more like guiding auspices rather than in the moment with metadata. And macro data is going to be talking about your multi-year trends and stuff like that. So all this data is rising out of there. And you think of this like an onion where you've got your core, and then here are here are science of learning, instructional design, course design, student performance. And out here are your teams: universal design, project management, instructional technology, software development. So the data is going outwards from the core and informing our teams. And we're trying to, do things from a theory-driven perspective where, but our theories might be informed by cognitive science, metacognitive engagement, social context and stuff like that. But at the same time, we're collecting data on the LMS. That's where the data is being collected from, is from the LMS, right? But here are our data analytics. And the reason I made them different colors is because I have to change my code base every 7 years here, but I have to change my code base every 3 months here. It drives me crazy. So you have to decouple these, right? I think of this as the engine of my car. And I want to keep my car for a while, but I can change out to a more powerful engine. That's how I think of that, right? And so what we're doing here is we're taking the data that's coming out of here. We're doing our analytics, and then here's where your analytics and your hypotheses collide, because they're either going to either confirm or disconfirm my hypotheses, which is going to reinform me as I go around in my cycle of improvement. So I want to design the learning experience. I want to collect the data. I want to analyze it, and then I want to refine my theory, and I want to do it again and again and again and again. And that's where what I was talking about before, the fast computation is going to help us here, because if I zoom out again, sorry, bear with me for a second while I find this mess down here. The different types of skills that we're tracking, the different types of skills we're tracking, if I kind of made this clunky, but language skills, academic skills, study habits, and social skills. And we view these as stacked upon each other in the dependency. Like if you have poor language skills, your academic skills are going to suffer, right? But if you have poor study habits, then your language skills and your academic skills are going to suffer. But if you have poor motivation and your attitudes suck, everything's going to go down in a dog pile. So what the question that we're asking, actually, this would be probably a better view of this, because I have them stacked correctly here. The question that I'm asking is how does my listening skills affect my attitude towards authority? I don't know the vector dynamics there. It's too complex. It's too hard to understand. Like this is so what I want to understand is like, do my listening skills impact my math more, or do they impact my social studies more? It's an interesting question. So, right. So I want to understand the dynamics of human development, and so I can do some control over it, right? So what I'm saying is that the challenges are here that human development is highly nonlinear. They've got unknown dynamics. It's highly dimensional. It's hard to measure. You don't know what your control points are. So if you want to create your sensors and actuators and do a control system, you're gonna have to be using stuff like sparse censoring. Okay, so like in the past we used to take many data samples, and then we used to derive our understandings from many measurements. But what we're learning is if we can find the sparse sample points, if we can find the important points to take the sample, we can take a few data points, and then we can use like single value decomposition, principal component analysis, and we can reverse that. We can actually begin to infer the dynamics of the system from sparse sampling, right? We can start to do that now because of the fast computation that we have. So this is where I'm headed. I want to know. This is not a good depiction of an autoencoder, but I actually want to know when there is some disturbance to the learning cycle that's kicking it off of optimal parameters. I want to read that, and I want to read the outputs, and I want to say, and then I want to do something to stabilize the learning. Right. This is where I'm headed, and that's where what we're learning now in the areas of computational engineering and stuff. That's what, Perry, to your point, right?
Well, could you jump back to the graphic that had the yellow and I think there was two colors side by side. I wanted to just make a comment that you could elaborate on. where you have the long term, the 7-year system versus the 6-month systems.
Oh, yeah, okay. So,
Because one thing we're finding, Dr. Ong, is that many companies have legacy systems, and it's too expensive to throw that away and start anew. But the way we've done it is it's so modular. We don't have to change the whole thing. We can just change the parts that matter and still use our legacy system for years and years and years to come, because it's got the right transmission, or whatever you want to call it, in the engine technology model. And that's something that I keep hearing when we're talking to potential partners, is they've got a whole bunch of patchwork quilts put together that they don't know how to get rid of without having to start right from the scratch.
no,
And that's pretty daunting.
you're talking about vertical integration, because you're right. We're coming out of a paradigm where everybody had cobbled together all of these different mixed match solutions, and they march this sort of a Frankenstein solution out there that clumsily works, right? But you can't innovate for the future on a platform architecture like that.
I see.
Yeah.
Okay, thank you very much for your time and for your impressive system. And we learn a lot also. And is there any question, Tom, Art, SP?
Yeah, I got a little small question for you. Just now you show me the one you have to user to select the grade and the subjects, right? I want to know if the grade and subject is predefined by the human expert or doing it by AI.
Yeah, we do those by human expert, but you could do them by AI, but I don't.
I see.
think, yeah, your question goes to something, another point.
Okay.
And it goes back to what Perry said. Can I replace Perry with AI? No. Your brain is firing like 10,000 trillion synapses per second. There's no way AI is going to replace Perry anytime soon. So the human will always be in the loop, and at some levels of what we're doing here, you need the human mind. It's the most amazing structure in the universe, and so that's
But also, Jeff, we're basing things on standards which are set by governments for states and other organizations for their profession, which also I think relates to your question, Tom.
Sure.
Okay. Now, what if I have 1,000 or million of the PDF or books that are important to this system? So I put them into the correct grade or the subject automatically?
I think you could come up with protocols for that. Yes, it would be a multidimensional analysis of some element out of each of those assets, right? So maybe you would take the first 5 pages. Maybe that was how I would start. I would say, okay, let me run a process that loops through all of these assets. It takes the first 5 pages and it does an analysis of that, and then we could start there, right? And then if that doesn't work, we would refine that approach until we really, and perhaps that would handle 75% of them, and you'd have 25% that we'd have to run through a different process. This is just the
Jeff, would that work if these PDFs are all in different languages?
Yep. Yeah. The LLMs are really good at if we use embeddings. So the nice thing about embeddings, Perry, is that you can mix, obviously with RAG, you can mix querying with your documents. So yes, you could, and it's multi-language, right? So it's no problem. It would be no problem to do that. Yeah.
My last question, please. For all these systems you're showing, are you using the hardware side, is a high end, like high GPU one, or may I know what kind of hardware the machines you are using for these systems you are working on?
Yeah, that's a good question. So it depends. So we just use GPU. We just use GPUs in the cloud, and for whatever the task requires, we will spin up that silicon. And then if it's a temporary job, we turn it off before it keeps charging us.
Let's see.
Yeah.
That's great. Thank you. So we can wrap up, and thank you very much again for
Our
very
pleasure.
in-depth. Yeah,
Thank you.
and very nice meeting both of you also.
Yeah, nice seeing
And
you.
Our pleasure.
yeah, we will give a lot of knowledge to our team also, and the system is quite impressive. I will discuss further with Mr. Lee and David also.
What's
Thank you.
our best way to get the recording to you?
Tom?
Is
If
it
this file, yeah, if the file is not big enough, or you can express it into the smaller size, and